Hello again, this is Ryan Navarro, Applications Engineer at Hawk Ridge Systems. And here we're picking up from a previous video where I talked about some of the aspects of the design of this 3D printed bell ornament for a design contest here at Hawk Ridge Systems. So if you're curious about the modeling process at all, please check out that previous video, which we'll link below. But here we're going to talk a little bit about validating the design, generating outputs from it, namely photo renders, and show you a finished result. So a couple of the things I did to validate the design as I was working on it, I was concerned with the center of gravity location, which we can display by turning on mass properties on the part. Typically you would want to make sure that you have a material defined. I knew this was going to be a homogeneous material. All the independent pieces would be made of the same material, so even if I didn't apply the correct density, the center of gravity location would be in the correct place. And I can see that visually on the screen. If I go to any of my views, I can see the center of gravity location represented by that triad in the center of the bell. And I just wanted to make sure that was centered and somewhere near the pivot axis. So I was happy with that. I knew that the center of gravity of the clapper would be much lower. So if we want to see that, we can click on the clapper body and see its center of gravity, so that if you initiate a swing from the hook, the clapper will swing in one direction and contact the side of the bell. Okay, if I wanted to, I could click Create Center of Mass Feature. That would put a visible feature on the screen to show me where the center of mass is located. But again, I just wanted to mostly make sure that it wouldn't hang at an odd angle with all this twist I added to it, that the CG was still in the correct location, is relatively symmetric. So the other piece of validation I want to do was making sure the clapper was the right length and would contact in a good spot on the body of the bell. So this is a multi-body part, which means that we cannot easily move the bodies around, can't just free drag them around. So we could do a move copy body command to rotate them to different positions, which you'll see later. But what I did here is common for what you do in a lot of master modeling or multi-body parts like this, where I did a save bodies command. So basically I just right-clicked on the solid bodies folder and did save bodies, and that gives you the prompt to choose the bodies you want to save. You choose all three bodies here. It's telling me they've already been used, so I would check all three of those options there, and then I click Create Assembly. And what that does for me is it saves each of these bodies into a separate part file and creates an assembly from them. So let's go ahead and take a look at that assembly. Okay, and initially when this assembly was created, all the three components were fixed in space. So what I've done is I floated the components I was interested in and applied my own mates to them. So this allows me to just free drag things, kind of pose the model easily and see how things would contact. We could even use things like our collision detection if we want, right? Turn on collision detection and get our notification when we have a contact. So that's just an easy way for me to visualize what's going on in a more fluid way. And I have to say I'm pretty happy with how this looks as it's in motion here. So that's one technique, and this is also anytime you are using a design that's done with a multi-body part and you want to represent the motion of it, this is kind of my preferred workflow. You see all these parts, all they have is a single feature that's referencing back to the original part file. So if you were to open up one of these parts, for instance, you could do additional detailing on it here if you wanted. But here it's just pointing me back to the original feature. So if I go to edit in context, it's just going to bring me back to my original model. Okay, so I mentioned the other approach you could have done is using the move copy body command. And that's what I did to pose this for a rendering. since I didn't need as much live detail there, I have some other configurations where I've posed it for rendering, and I may need to roll down in my feature tree to show you these. So here I've just added a little hook that I might want to be in the rendering. If I go to this other pose here, I just call them poses. It's like a model, posing a model, right? CAD model in this case. We can see I've manually created a section view by just cutting away an area, and then I did some of those move, copy, body commands to rotate the parts. So these are just saying rotate the part body, whatever I said, 342 degrees. It was probably a free drag that I did just to visually get it in a spot that I thought looked good, and then rotate this other piece about an axis I had there. So I got it to an area where I thought it looked pretty good. Then what I did is I used SOLIDWORKS Visualize to render this. So you could also use PhotoView 360 if you want. That's the renderer that's integrated within SOLIDWORKS. But it's very easy for me to dump this model over to Visualize. I just came over here and basically did an export simple, I believe. That brought me into SOLIDWORKS Visualize. So here I'll open up the Visualize project for you so you can see what I did. Again, SOLIDWORKS Visualize is included with any license of SOLIDWORKS Professional or higher on active subscription. And it's really our great new rendering engine. So you can see here the rendering happening on that model that I posted. I think I didn't even apply any custom materials or anything in Visualize. I definitely could have if I wanted to, but really easy to just get this thing to look pretty nice. And we could try out different environments and things here if we wanted, right? Easily switching environments and seeing how that affects the lighting, right? Every change you make will have some subtle change in the lighting there. And I knew in my mind I wanted to make like a little postcard. So what I did is I rendered this out with transparency. So that created a separate PNG file, a transparent graphics file. I was even able to capture the shadow in transparency, so that enabled me to very easily go into a program, image editing program, and paste in the bell with its shadow as a transparent layer, and make my little greeting card here. And this was also, again, I consider it, if you're doing product design where the appearance is important, this is also like a validation step, because I talked about earlier, this thing's only 2 inches tall, so it's hard to picture what it's going to actually look like. But you may want the most realistic representation you can, especially if you're making a purchasing decision. If you're about to buy an injection mold that's thousands of dollars, you really want to make sure that everybody involved is happy with the way that thing looks. You might know it functions great because of SOLIDWORKS, right? Because of your CAD model, but you don't want to invest tens of thousands of dollars in tooling and then find out that it's ugly. So that's the logic behind doing some rendering. It's also almost design validation in a way. So that's what I did there in SOLIDWORKS Visualize to set that up. Again, that's my preferred rendering tool, definitely anytime I want a really high quality image. And then finally, we'll talk a little bit about the end result. You can see on the screen an image of the part coming straight off the print bed after it was partially post-processed. Some of the powder was blown out of it with compressed air there from our HP 3D printer. And then it's got kind of a light gray natural color by default, and it was dyed to this black color here. And you can see the precision of the detail. So those little holes on top are about 1 millimeter diameter. Again, this whole thing was 1 millimeter wall thickness. I've had parts printed for me on the HP down to under 0.5 millimeter wall thickness. Features under 0.5 millimeter even. But you can see even that little faux Phillips head screw indent I have there was very well resolved by the printer. Again, you have to remember this thing's tiny. 2 inches bounding box around the whole thing. aside from the detail, these 3D printed models are also quite resilient. I've had a couple other ones made similar structure to this and can drop them from quite a height and they'll just bounce. I've yet to have any fractures or anything like that. So along with that high detail and resolution, you're also getting a fairly functional strength part out of here. And I even have video. Now, from the beginning, I was curious if there would be a sound or how much sound would come out of it, since it is all plastic. So I'd say the sound of this thing isn't really its highlight. If you watch this video, you hear just a faint little clack sound from it. But that clack to me is reassuring because it's telling me that the mechanism is functioning the way I want. Again, this was an as printed mechanism. We had about 0.5 millimeter clearance between any wall, which was just a number I chose. I thought was a reasonable value for the printer. I hadn't actually printed an as printed mechanism before on our HP, and I was really happy with the result. I don't think of anything I could improve on this one, and I'm happy to be able to do challenges like this at Hawkridge. It's a fun thing. You know, some people think we just do CAD all day, which is true, but we do have plenty of opportunities to, you know, stay involved with physical products like this. So I'm kind of just trying to go back through and document some of those, so you can stay tuned for more videos and more content on things we've actually made in the past. I kind of want to get that message out there that, you know, it's an interesting experience to kind of just, we have all these great CAD toys that are available to us, and then being able to put those into practice and stay sharp on our design skills. So hopefully this video was helpful to see a little bit of the process, these two videos of some of the design thoughts that went into this, and then also the final output. Thanks for watching.